It's my pleasure to introduce Mr. Bruce Milne. He is the Chief Marketing Officer at Pivot3. Bruce, thanks for joining us.
Thanks very much, and appreciate everybody joining us today. As mentioned, I'm Bruce Milne. I'm the Chief Marketing Officer for Pivot3. We are a hyperconverged infrastructure vendor based in Austin, Texas, with operations around the world. We have about 2,600 customers. We've been doing this a long time, and we're one of the leaders in the space, especially if customers have mission-critical applications where they need resilience, security, and manageability at scale to be able to support those applications. So today I want to talk to you about intelligent infrastructure and how that intelligence is required to efficiently manage hybrid cloud, IoT, and smart cities type implementations on hyperconverged. As I mentioned, Pivot3 is really focused on supporting customers that have mission-critical applications and business services in mission-critical environments. And we focus on ensuring and automating the security, resilience, and manageability at scale of those applications so that customers can realistically deploy more and more applications with more and more data and more business service capability on the same infrastructure without having to incur additional costs in terms of personnel to manage that, being able to set and forget the implementation and have it self-manage, monitor itself for resilience to make sure that the system stays up and running, it meets its SLAs and that sort of thing. So we're going to talk about how we accomplish that and what the key requirements are. But let me set the stage just a little bit before we started. You know, I was at a conference with Gartner and they did a poll of the audience, and it was surprising that CIOs were responding that up to 80% of their business depends entirely on IT for their very existence. All their business services are supported by IT now. So I think this is actually an understatement, as some of the CIOs mentioned to me after the fact, that 79–80% doesn't cut it for us. It's almost 100% of our business is dependent on IT. So that puts a lot of pressure on IT, which heretofore wasn't necessarily so central to the operation of the business. And sort of to pile on a bit, if we just look ahead by a couple of years, you know, in the transport industry, for instance, by 2020, 3/4 of the cars on the road will be connected, and they'll produce upwards of 350 megabytes of data per second. This is just one example of an IoT type deployment and the types and volumes of data that it's going to create. And this is streaming media, right? It's coming in constantly. You have no predictability as to how many sensors might turn on at any given time. This is everything from biometric data to telemetric data to self-analysis of the vehicle and all its operating systems, back to a data center or perhaps to applications within the vehicle at the edge to do some self-analysis and self-correction. There's all kinds of new data and, as a consequence, new applications to support those data that are being created by this IoT environment. And the needs that this creates and precipitates are enormous. What's interesting, though, is a lot of the data being created, upwards of 2/3 of the data being created, is from surveillance data capture, that is security type applications, increasingly safe cities, smart buildings, safe campuses, safe transit, smart casinos. These types of applications are generating enormous amounts of data. Somebody has to manage all that data and store it reliably and take action with it, learn from the information that's embedded within the video data. And of course, the IT challenges that this creates is that internal customers, line of business customers, are asking IT to respond more quickly, to help them deploy business applications faster, to store enormous amounts of data about their particular operation and analyze that data. So the IT organization is under duress, while at the same time they're having to deal with delivering storage performance, capacity planning and forecasting, the high cost. They're not getting more budget in order to support all this. So how can I do this most efficiently? Are there cloud options that offer me a more economical model for long-term data storage or even short-term close-in data storage? And can we realistically use a medium like the cloud and expect the response time that's demanded from our lines of business? So it creates a very complex environment. It's no longer simple to just deploy a new business service for a line of business. There are many, many demands on IT to do this, and the growing end user expectations, of course, are creating a level of anxiety for IT that is unprecedented. So what IT really needs is the agility to support these modern business needs. If there are going to be that many devices attached to the internet and creating data and creating demands on IT, the CIO has to be able to accommodate those new dynamics in the marketplace, the new demands internally from IT, and determine whether the cloud or putting compute capacity out at the edge or bring it into a core data center or some combination of all three is actually the right approach to supporting those needs. And figure out how they can take advantage of all this new information to create new business services, new economic models for IT. So how IT is reacting is to quickly transition to what we call hyperconverged. And you're probably all familiar with the term, but there are variants on hyperconverged, whether it's hyperscale SAN storage in the cloud or whether it's on premises. There are different types of deployments. Most hyperconverged platforms, for instance, deploy as a hybrid cloud on premises. Increasingly, the more advanced hyperconverged platforms can also burst out to public cloud infrastructures or cloud service providers as natural extensions of your on-premises infrastructure. Some of the even more advanced ones can federate your capability in the core data center with what you're doing out at the edge, put compute capacity and storage capacity at the edge where the data is being captured, but also manage that in concert with, in a federated model, with your on-premises infrastructure and increasingly what you're doing in the public cloud. That's all replacing traditional approaches like three-tier storage area networks and so forth. So we're seeing a rapid adoption and very quick conversion to a hyper-converged model, which is much more agile, much more responsive. You can expand it, start small and expand it quickly, both on the storage capacity vector, but also on the processing vector. So it's really transforming how IT meets the needs for line of business to deploy new applications very quickly. It combines all the capabilities that you have in the data center, your storage, your networking, your memory, your processing, into shared pools of resources that you can deploy against those applications, host multiple applications in the same infrastructure, and expand it, start small and expand it very easily with commoditized off-the-shelf hardware with this new operating system layered in to be able to add it to the pool and use it as part of that shared resource capacity. So the reason that customers are doing this, the reason that they are deploying hyperconverged is, one, the agility, but just as importantly, the economics. It's less expensive. In many cases, we're deploying hyperconverged implementations that replace three-tier infrastructure because the cost of the maintenance on the three-tier infrastructure is actually more than deploying a brand new hyperconverged platform. And it's easier to install and operate and staff and manage. You don't have to have traditional advanced IT skills like storage capacity planning or network architects on staff. More IT generalists could administer very, very large deployments of hyperconverged from a single pane of glass with a higher degree of automation, so there's less technical requirement on them. You can use IT generalists to do what previously was the domain of highly trained IT specialists, which are more expensive and hard to retain. So CIOs see this as an approach to addressing the fact that upwards of 4/5, 80% of their business is now completely dependent on IT to support them. Now, that obviously is precipitating, these new technologies are precipitating all kinds of new applications as well. So people are thinking about the computing capacity very differently and what it can do to support them and make either lives better, cities more livable, campuses more safe. And these are the types of applications just in the IoT world that we're seeing as a natural extension of what had previously been basic security, data capture and management of the video from high definition video cameras in a surveillance context. Now we're seeing access controls and facial recognition, biometric data collection, HVAC in a building, a smart building, managing the street lights. All these things are safety related as much as they are efficiency and livability related. So we're seeing an enormous increase in the number of adjacent applications that have come out of the advent of true commercially available and economical IoT. So again, hyperconverged is being put into practice to be able to support this expansion of IoT use cases. And again, I'll sort of reiterate that this is happening at the edge where data is being created, in many cases captured and processed and managed. At the core, where in some cases the data is being pushed to a central repository where it might be for long-term storage, or it might be for processing big data and doing analytics against that. There are all kinds of reasons why customers keep on-premises resources and manage a data center, not the least of which is security and manageability. But increasingly, customers are also experimenting with what they can move to the cloud. And what many cases our customers have told us is that they bought into the cloud value proposition of simplicity and economics, and turned out to be neither simple nor economical to move stuff to the cloud when data collections became very large, or they wanted to host in a higher tier of service in the cloud. And of course, the cloud service providers and the public cloud infrastructures don't make it super easy to repatriate those applications or those data when you decide that you don't want to use them in the cloud anymore. So that's one of the things that we have automated to make it easier for customers to take advantage of capability at the edge in their core data center and out in the cloud. IT, of course, is under a huge amount of pressure to meet the top business priorities, and you'll see they're very out of sync in many cases. Innovation and new projects is a very small percentage of the time. A huge amount of time goes into babysitting the applications that are already in place and doing things like software installation, upgrade, and basic babysitting of applications, which consumes a lot of time and keeps them away from deploying new applications and business services, or improving efficiency and productivity, or growing company revenue. The things that keep the CIO up at night are very different from what the IT team is able to spend time on. Once again, Hyperconverged addresses this head on, and automation, of course, allows them to step away from those traditional uses of their time and focus more on what the business priorities are for executive management. So Pivot 3, as our approach to this is to create connections between your private cloud, which can be on premises, or it can be at the edge, or it can be federated capabilities in both locations. We connect those together and allow you to manage your applications and data in both locations. And we've also created connectors to the public cloud so that you can extend those capabilities, extend your capacity out to cloud infrastructures, whether that is burst capacity for short-term or longer-term, long-term retention, storage, management, hosting of your applications and data. What also is very valuable to customers is helping them make informed decisions about the right tier of infrastructure to engage in the cloud. Where should I host data if it is required for active use in applications in real time and I need access to it all the time, or if it's data that is for long-term retention and stays at rest for most of the time. That will determine, for instance, that's one example that will determine what's the optimal tier to host that application or those data. So Pivot 3 has created a platform of hyperconverged capabilities that is deployed on core infrastructure, on hardware in your data center. It's deployed on edge components, that is, servers deployed at the edge for data capture and processing, but also in the cloud. We have an operating system that operates in AWS and Azure and so forth, and they all work together. That software platform provides capability in the categories of performance and data protection, placement of data and applications, security, and ultimately monitoring and reporting to make sure that it's all operating well. But each one of these components in and of itself and taken together is intelligent and uses artificial intelligence, machine learning, advanced analytics to automate these functions to a large degree so that it requires less hands-on management and administration from an IT administrator. On top of that, to support some of the specific business requirements, like a safe airport, like a virtual desktop implementation in a secure environment, maybe a business continuity disaster recovery use case, we support all those use cases with solutions that comprise both our platform and intelligence engine, but also third-party componentry, integrations, certifications of different technologies, perhaps best practices and templates for success. Because we've done this many, many times with our customers, we're actually providing customers templates and benchmarks for sizing, t-shirt sizing of small, medium, and large, depending on their requirements. This all makes it easier for the customer to deploy these applications and business services, but also decreases their time to value. So it accelerates their time to value, reduces their cost of ownership at the outset and for the long term, and then automates the capability of monitoring and managing those applications and that infrastructure so as to reduce the amount of resource they have to apply to keep them up and running and make sure they meet their SLAs. That intelligence engine is really core to being able to scale to large enterprise scale of deployment of applications and business services, but at the same time meet your resilience requirements, that assurance that the applications are going to stay up and running even in harsh environments, even under duress, even through hardware failures. We provide capabilities to support all of that, and to make sure that it's secure, because increasingly there's pressure on IT to make sure that the data is secure regardless of where it resides. Under the hood, under each one of these categories, there are many, many features and capabilities that Pivot 3 provides, and we add to this virtually monthly to create a more and more robust intelligence engine that will automate fully the administration and management of the infrastructure supporting all their business services and applications. Again, this frees up IT to focus on the things that executive management cares about, and less on the things that have occupied their time previously, like integration of technologies or monitoring the drives for likely failures. All that stuff is fully automated in the Pivot 3 environment. One of the things that we automate is the ability to dynamically reprovision resources to your most mission critical applications based on the priority of those applications over others. So your Exchange server and email, because it's sort of a batch application where customers are quite okay with waiting 1 or 2 or 3 minutes for an email to arrive, that is a lower priority application, must be up and running, but doesn't have to meet a certain performance SLA, compared to, for instance, the point of sale application, where that has to be up and running during business hours and it has to be sub-second response time, or customers will abandon shopping carts. So the priority of those are very different depending on the time of day. And obviously, relatively speaking, the point of sale application is going to be more critical. So you can define that criticality in our policy management engine, and it will dynamically reprovision resources to make sure that application always meets its SLAs, its service level agreements, the minimum performance and availability requirements and security requirements. At the same time, making sure that the other applications, lower priority, do get the resources they need when those resources are freed up. So it's constantly making resources available as demand waxes and wanes on the key mission critical applications. And you'll actually see dynamic provisioning of resources as the demands increase. We talked a little bit about security, so just to explain how these policies work, here's an example of security via policy, where you can say at the application level, at the volume level, at the array level, that you want all application data at rest, or all application data in motion to be encrypted. You can do it by user class, you can do it by individual. This is all fully automated, so all data in and out of the system in this particular case would be encrypted. You can be very selective about what gets encrypted. We've optimized these integrations so that the encryption doesn't reduce your performance on the system, and we've incorporated NVMe to accelerate processing speed on basic off-the-shelf hardware. So we're getting more performance out of commodity hardware than the closest competitor is by 3 to 7 times the performance in some cases. So that makes this invisible to the end user, that you're actually encrypting all the data in real time as it comes and goes from the system. That would normally have a pretty substantial performance tax on it. So again, fully automated, set and forget type mode by policy, so that IT doesn't have to spend all their time monitoring these applications and making these changes to data services. And to support all of that, we have intelligent monitoring and analytics that do things like proactively identifying when a drive is going to fail. When we see, redundancy errors, redundancy checks coming up in hard drives, for instance, we can identify that is likely to fail. We will void that drive, remove the data from it, spread it across other drives in that node or across the array, notify the user, send out a new drive. When they replace that drive, it automatically repopulates the data and adds it back to the array. That type of automation just makes things super simple for administrators. In fact, we have many situations where customers have told us that over 5 or 6 or 7 years, they've never lost a byte of data. And these are non-technical administrators that are managing these systems that are a very large scale, 275, 300 nodes, 7 petabytes of data, for instance, and never losing a byte of data. That's critical for them. That's the type of capability that we provide from our intelligence to automate these systems and make it easier to administer and manage at scale. Now, how does this matter? Well, what we're seeing is an increase in in the value of the system to IT and to the overall organization. So for instance, we've reduced the cost per knowledge worker of a desktop for virtual desktop implementations by half against traditional software-defined storage type implementations, or traditional virtualization by 25%. So we're seeing enormous gains in efficiency and manageability and the cost of ownership by applying this automation and intelligence. Same is true in cost per transaction in a transaction-oriented type application like a point-of-sale application. 10 cents per transaction, fully loaded cost, versus something like 18% in a traditional virtualized environment, or 14 cents per transaction in a software-defined storage type model, more traditional, 2-3 tier architecture or converged systems. So the ROI from Hyperconverged is obviously better than traditional approaches, but Pivot 3 with our level of automation and the intelligence engine improves that even further. So just to recap, Pivot 3 is really about helping customers with mission critical applications and business services to deploy that at enterprise scale by automating security, resilience, and manageability. Through our intelligence engine, we provide the most robust deployments in the industry, as evidenced by some of the largest deployments in Hyperconverged anywhere, like 25 petabyte deployments in large transit systems, and customers around the world depending on us for mission critical deployments in hostile environments. So we're excited to talk with you today. Appreciate your time. And now we can ask a few questions, and if you have any questions from the audience, I'd be happy to take those now.
Yes, great presentation, Bruce. Thank you. We do have a number of questions here for you from the audience. Let's see. First question that came in, they're asking, what are the limits on your business policy management feature, and how many virtual machines can you manage with it?
There's no realistic limit on the number of virtual machines that you can manage under the business policy management system. It's designed, again, to scale to enterprise volumes. We've seen customers go from, a dozen or maybe 10 or 15 or 20 virtual machines under management to hundreds, each supporting individual business services or applications or instances of applications, instances of virtual desktops without incident. So it's fully automated at effectively any scale. No critical limit.
Very nice. Okay. And then another question here, they're asking, can the servers be distributed, or do they have to be located, physically to be managed by the Pivot 3 solution?
That's a good question. This is critical to remote office, branch office type deployments. So we work with a number of major logistics companies like FedEx. We work with a number of transit authorities where they have multiple stations where the trains pull in and so forth. All those nodes at the edge, right, where they're collecting data or managing applications out there like access controls and turnstiles and point of sale and so forth. They have to be federated so that you can simplify the administration of it, and you're probably not going to have IT specialists out at those edge locations. So the answer is you can have infrastructure anywhere. As long as it's connected by network, we can federate it all and manage it all from a single pane of glass that's centralized under one IT administrator.
Very nice. That's very efficient. So another question here, they're asking, what's your largest deployment?
Our largest deployment is 25 petabytes under management. That is, again, a municipal transit authority for the nation's capital. Pretty exciting deployment there, where they have expanded their use of the security applications into core infrastructure, things like point of sale and turnstiles and so forth, all the machinery for for buying access to the transit system, but most importantly, the analytics for facial recognition, crowd capacity planning, identifying threats when they hit the curb or when they hit the platform. Number of advanced analytics for things like loitering detection. So their needs have expanded enormously beyond storage to processing as well.
Very nice. And then here's a question I'm curious about that just came in. They're asking, can I run IoT and video collection workloads on the same Pivot 3 clusters as traditional applications, or do I need to silo those off?
No, you don't need to silo them. That's the benefit of the business policy management. Is it's going to treat all the different resources like storage, memory, processing, networking as individual resources that can be applied and provisioned to those various applications depending on their needs. So if your data collection application for IoT and streaming media has to be up and running all the time, and that becomes a mission critical application. You don't want to lose any data, so it will apportion all the write capability required to capture that, and even the cache capability in memory to be able to support the ingest rate that you're realizing from those sensors. But at the same time, your analytics applications, or perhaps your virtual desktop, or just enterprise applications like your Great Plains accounting system, for instance, that can also be hosted in the same implementation, and the business policy management engine will treat that one according to its requirements and make sure that it gets the resources it needs to be successful. So the business policy management engine at the core of the intelligence engine is really the key to being able to support those multiple mixed workloads in the same infrastructure without incident.
Excellent. Well, I think that's all the time we have in today's session, but thank you so much for being on the event today, Bruce.
All right, well, I want to thank everybody for their time. You can see that there's contact information here on the screen. We look forward to speaking with you about your requirements for hybrid cloud, IoT, safe cities, and other use cases. So thanks for your time.